Okay, let's start the class. Okay, so today we are discussing about remaining backups. Like in the previous class we discussed about the different types of backups, right? So we discussed about the full backup, differential backup, transaction log backup and tail log backup, and the backup strategies which we are using in real time. Okay, so today we'll discuss about the remaining backups. We have backups like copy only backup, okay, and mirror backup, and we have split backup, and we'll see how we can utilize this backup in real time. I will try to explore. Okay, so let me open the SQL server. See, split backup in the sense, basically example, full backup means, see, whatever the content we are taking at the database level, all this content will be storing in one full backup, right? So example, you have a database size is around 40 B. If you want to take the backup for particular 40 B of database, it will take 4 hours. Imagine it will take 4 hours. Okay, but you have, but the customer is allowed only 1 hour to take the backup. That means that is the customer application team requirement. Okay, see, in this case what we have to do, we have to check the possibility like backup types. Okay, we have to initiate the backup, okay, with split backup. Okay, split backup means we are splitting the backup, okay, to the different drives. Okay, example, imagine I have 4 TB of database. Normally it will take 4 hours, okay, if I take full backup. But if I take this same backup using split backup, it will finish in 1 hour. What I will do, I will create, like I will split the backup files in different drives. Okay, like split backup 1, split backup 2, split backup 3, split backup 4. Okay, I will split same data dump to the different files. Okay, that means it is creating the 4 backup file. Okay, at the same time while performing restoration we have to like use all these 4 files, then only our backup will be succeeding, like restoration will be succeeding. Okay, so it is helping if your database size is very huge. Okay, so basically what happens if you open any drives, so each and every drive we have a C drive, D drive, F drive. So we are having the drives like this, right? So in real time also we are having different drives. For the backup, one drive. For the data files, for storing the data files we are using one drive. For keeping all the logs we are dedicatedly using for one drive. For the temp DB we are allocating specific drive. Okay, like this we are maintaining multiple drives in the real time. Example, if you have a requirement to take split backup, we can split data into the different files. Okay, we can reduce the time. That means for each and every drive level we have a disk reads per second, disk writes per second. For each and every disk it is allowing certain number of reads per second, number of writes per second, right? Example, if you keep all these data files, log file, backup file, all these things in single drive, okay, so it is burdened to the that specific drive, and it is burdened to the LUN that drive is mapped. Okay, so that is the reason we are like maintaining multiple drives for each and every type of data, every type of file. Okay, so in our case, in log, like in split backup case, okay, so in the same way I will be like splitting our my data to the different drives or different files. So what happens, so it will finish operation faster way. Okay, but one challenge is here is, like while restoring we have to choose the same sequence. We have to restore all these files at a time. We cannot restore one by one. Okay, so let me connect the server and let me show you how it will work. Okay, I'm just checking for the query. So we have the database. Okay, example, let me take the demo db. Okay, if you want to take the backup, full backup, you directly taking by right clicking database, go to task. Okay, backups, you directly taking the backup file using this option, right? If you want, you can specify the full differential log. Here I'm just taking the full backup. You just remove this path, you just add the specific path to take the backup. Okay, example, I want to take these backups in this b5 folder. Okay, I want to take all these backups here, so I'm taking demo db, demo underscore. You can always follow the separate 20220747 underscore full dot bak. That means it is captured, it is capturing all the data. Okay, so it is keeping this specific data file in specific path. Okay, so let me show this d drive b5. Under b5 we have a backups. This is the like today, like this is the latest file. Okay, it is having like almost 2.8 MB. It is like almost 2.77 MB, right? Example, I want to like split this backup to the different like drives. Let me check the query. Let me take the query from the Google, like yeah, this is the simple command. So let me open new query window. SQL server is SSMS is not responding. Okay, okay, so this is the command like backup database name. What is our database name? Our database name is demo. Okay, to disk is equal to path. What is our path? D drive. Under D drive we have a b5. Okay, and the type of like demo underscore split 1. Okay, split 1, and I'm adding one more file that is in the same drive, but I'm taking this in b4, like in b4. Okay, demo underscore split 2 dot bak. Okay, so I'm taking, we have a b4 folder here. Okay, and we have f drive. Let me take the backup here. Okay, under f drive, f, so demo underscore split 3. So here with format is the syntax. Okay, so with format is the command, like we have to take this split backup with no format. Okay, so skip, no rewind, okay, no unload, stats. Okay, stats means, so if you specify 10, it is displaying the status when 10% is completed. If you specify like 5, it is displaying the status for every 5% is completed. Okay, so this is the backup file name. Okay, so this is a simple command to take a split backup. So we are taking backup in, see, I am taking backup in the D drive b5 folder. I am taking backups in the b4 folder in the same drive, and also I specified the f drive. Okay, that means I am taking backups to the different drives at the same time, different folders in the same drive. Okay, let's see. See, backup has been completed. Okay, you can check the backup files now. Here it is created the backup file like split backup. Okay, it is having like 982 KB. Okay, go to this D drive, under B4 check the backup, it is having 982. Okay, and you can also check here. Here you have a split one, it is like 1047. That means it is splitting the data to the different files. Okay, so like this we have to take the backup in order to reduce the backup time. Okay, so we can take we can take up to 64 split backups. Okay, we can take up to max 64 backups. We can take like 64, we can specify like 64 split files. Okay, that is a max limitation. So here, so mostly we are using this option if your database is huge. Okay, so next we have a copy only backup. Copy only backup is nothing but a, what is copy, what is the meaning of copy? Copy means, what is a copy? It is like one more file, right? So in order to take this backup, okay, so we have to specify the separate syntax. Let me check that. I'm just checking for the copy only backup with copy underscore only. I think that is the command. Let me see here. Backup database name demo. Okay, to disk equal to path. So I want to take this backup in B5 folder under D drive. Okay, demo underscore copy only dot bak. Okay, so we are taking this backup with copy underscore only, this is the syntax. Okay, see example, each and every backup is having LSN. Okay, each and every backup is having LSN. So whenever you perform any backup, that backup is having like first LSN, last LSN. Okay, so sometimes what happens, we have high availability technologies. Okay, we can imagine we have a log shipping. Okay, log shipping is one of the database level high availability. If you configure log shipping, it is copying the log backups from one location to another location. Okay, in this case, if you take, like, it is automatically taking the backups and it is copying to the different location. That is a log shipping mechanism. Example, if you manually take any ad hoc backup, it will impact, like it will break the log backup chain. Okay, to avoid this kind of issues, so we have a concept called log copy only backup. Okay, if you want to take this copy only backup, we can take at any time. Okay, by simply specifying copy underscore only. This is a command to take the copy only backup. Okay, so if you want to take this using GUI also, we can take this backup using GUI. Just go to this task, backup. Okay, see here you have a copy underscore only. That means we'll take this copy only backup without interrupting to the workload. That means sometimes if you take this copy only backup directly, okay, by specifying this copy only backup, so it is impacting the LSN. We call it as a log sequence number. Okay, to avoid this kind of issues, we are taking the copy only backups. We can take copy only differential and copy only log backup as well. Okay, so just run this. It is just acting as a normal backup. Okay, if you want to take the copy only log backup, you can like follow the same process. What is the command to take the log backup? Log. Okay, log.trn is the extension. Okay, like this we have to take the copy only backup. It is just for not interrupting the LSN. Okay, so next we have like mirror backup. Okay, mirror backup is nothing but a full backup. Okay, so example, you want to take full backup, okay, twice. So what we'll do, so we'll take this full backup in different path. Okay, in both the files we are having same data, but if you want, like if you have such kind of requirement, example, so you want to keep your backup in like URL, like in the cloud, and at the same time you want to maintain and you want to trigger one more backup in the local drive. In this case we'll take this, like we'll use this mirror backup option and we'll insert the full backup. It is just like full backup, but we are taking two full backups. If you want to take three full backups, we can take up to 4 mirror backups. Okay, it is nothing but a one more, like it is nothing but a full backup, but we are taking full backup to the different files. But in the copy split backup, we are taking full database backup and we are splitting the files to the different path. Okay, but here it is same as full backup, but we are taking based on requirement, we are taking full backup, 2 or 3 full backup. Maximum we can take the 4 full backup at a time. Okay, so let me check the query. Mirror backup in SQL Server.
సార్ కాపీ ఓన్లీ కూడా సేమ్ కదా సార్?
No. Copy only.
కూడా
Yeah,
full
copy
backup.
కూడా నథింగ్ బట్ కాపీ ఓన్లీ లాగ్, కాపీ ఓన్లీ ఫుల్ తీసుకోవచ్చు. బట్ కాపీ ఓన్లీ బ్యాకప్ ఏంటంటే వితౌట్ ఇంటరప్టింగ్ టు ద యువర్ ఎల్ఎస్ఎన్. అర్థమైందా? ఇప్పుడు ఎగ్జాంపుల్ డేటాబేస్ బ్యాకప్ తీసుకునేటప్పుడు ఎల్ఎస్ఎన్ అంటే మీకు చూపిస్తా, వాట్ ఈజ్ ఎల్ఎస్ఎన్ అనేది మీకు చూపిస్తాను. ఆ ఎల్ఎస్ఎన్ మిస్ అవ్వకుండా కాపీ ఓన్లీ బ్యాకప్ తీసుకుంటాం. ఓకే, ఇక్కడ నీకేందంటే మిర్రర్ బ్యాకప్ అంటే ఇట్ ఈస్ నథింగ్ బట్ ఏ ఫుల్ బ్యాకప్. One second. It is a split backup. Okay, so while see like this we are taking the split backup files. While restoring we just have to specify the all the backup files like this. See here. We have to restore at a time. Okay, all the backups. I think this is split backup. Okay, copy only backup. I will provide all these links with you. Okay, no problem, you can go through this. Copy only, this is log backup, that is full backup. Okay, I'm just checking for the syntax for the mirror backup. It is just one keyword, that's it. Mirror to disk, I think. Let me confirm. Mirror to disk, yes. Okay, so backup database name. What is our database name? Demo. Okay, to disk is equal to path. You just copy the path, like D drive B5 and demo underscore mirror 1. Okay, so it is nothing but a one full backup. Okay, if you want to take this, if you want to take one more mirror backup, you can specify here. Mirror is copy, nothing but a one more copy, right? So that's the meaning. B5 demo underscore mirror 2. Okay, here I am taking 3 mirror backups. Okay, so b5 mirror 3 with format. Okay, so this is a command to take the mirror backup. That means along with the full backup I am taking like 2 more full backup, total 3 full backups. Okay, basically there is no, if you take these full backups, okay, there is no use. Okay, but we have option. Okay, we can take this with the format option. Okay, it is working with format. Let's see, so it is just trigger, right? Let's see the size of the backup. So mirror 1, okay, it is having same size. That means it is automatically take the 3 copies of data. Okay, so this is all about like types of backups. Okay, so any doubts on this copy only backup, mirror backup, and split backup? We can take maximum 4 mirror backups. Okay, and split backups we can take up to like 64 split backups. In real time we are commonly using this backup. Okay, full backup, differential backup, transaction log backup, tail log backup, and split backup. These all are the files like types of backup we are commonly using. Okay, copy only normal, very rare case we are using this one, but mirror we don't use this mirror backup, because if you have one backup file full backup, that's fine. Okay, it is not required to maintain multiple full backup. Okay, any doubts on these backups? So okay, so next we have like if you don't have any doubts, I will move on to the next topic, that is like okay, I will move on to the next topic, that is like how the data is organizing inside. Okay, that means we are just creating the databases, right? And it is automatically creating the number of like data files and the log files, right? So in case if you insert any data, okay, that data might be like where customer might be, application might be like inserting data in the form of images, in the form of like large objects, or they might insert some videos. Okay, that means their like application might having different kinds of types of data. Okay, sometimes it is like getting huge blob objects, we call it as a large object, LOB objects. Okay, so what kind of mechanism it is internally having, like basically it is inserting data in the form of pages. Okay, in the form of pages. Okay, so basically we have a databases, right? Inside the databases we have file group, right? Like inside the file group we have a files, we are actually storing the data into the files, right? So later we have like inside the files data will be storing in the form of extents. Okay, and extend is nothing but it is a combination of multiple pages. Okay, that means data is storing in the form of pages. Okay, finally data is storing in these pages. Okay, so we have a page architecture, different types of page. What is page? First of all, page is a storage unit. Okay, it is a storage logical, it is a storage unit. Okay, so what is the size of this page? Okay, we have a dedicated size for this page. Okay, each page size is KB, 8 KB. Okay, page size is 8 KB. Okay, so here we have a different types of pages. Okay, so types of pages means we have pages called database. Okay, and we have a page called pf page free space pfs, page free space pfs. Okay, and we have pages called like gam and sgam, like index allocation mapping. Okay, and we have dcm, differential change mapping. Okay, and we have a page called gam, sgam, dcm, pfs, page free space, image, image also. I think image is coming under database only. Okay, and next we have like boot page. Okay, example, if I want to open my laptop, so by default internally it is like operating with opening starting my laptop with boot pages, that like we have boot up options, right? So in the same way for the SQL server we have a boot page. Okay, that page id is one. For each and every page we have a id, specific page id. Okay, like this we have a different kinds of pages we are having. Okay, so let me check the pages internally. So these are the pages like data page, index page, or image page. Okay, gam, sgam, pfs, iam. Did I write down the pfs here? Yes, pfs, iam, gam, sgam, bcm, dcm. Yeah, I missed the bcm. Okay, next bcm, bulk change mapping. Total we have a 9 pages. Okay, index you can also call it as image or text. Okay, data pages, index pages. Yeah, see here these are the types of pages. Okay, data pages means it will store the exact data pages. Okay, normal data pages. Okay, in the form of inside the pages data is allocating in the form of blocks. Okay, log blocks, we call it as a log blocks inside the, but we don't have any specific size for this block, but we have size only for the page. Each page size is 8 KB. Okay, and inside the pages data will be storing in the form of log blocks. Okay, that page might be data page. Okay, data page means it is like it is storing all the data pages. Okay, next pfs, we have a page free space. Okay, free space is nothing but a example. I just enter the space bar, that means it is also considering one space. Okay, so this is also allocating some amount of size. Okay, so in SQL server this is this is also having 8 KB of size. Okay, we call it as a page free space. Okay, next gam, global allocation mapping. Okay, so shared global allocation mapping. Okay, what is gam and what is sgam? Gam means example, we have it extends, right? Extend is nothing but a combination of pages, right? Extend is nothing but a, it is a combination of pages, or it is a continuous 8 pages. Extend size is 64 KB because 8 pages are equivalent to the one extend. Okay, 1 into 8 pages are equivalent to the one extend. Okay, one extend, what is the size of one extend? It is a 64 KB. Okay, so it is a 64 KB. Here GAM means shared global allocation mapping. It will stores the information about the extents. Okay, store the information about info about the extents. Okay, and it will also like maintain same stuff, same kind of information, but it is having some functionality, said global allocation mapping. See, both GAM and SGAM both are using for storing all the allocation related to the extents, but here we have like uh, here it will not store like free spaces, page free spaces. Okay, that means like it is telling to the SQL Server engine to avoid mixed extent. So I will tell you what is this mixed extent, what is this uniform extent, but you can note down like GAM and SGAM both are same. These are using for, okay, storing information about the extents. Okay, I will come to this GAM and SGAM differences later, because by in the extents we will get to know that. Okay, next, IAM, index allocation mapping. Okay, index allocation mapping in the sense, inside the table we are creating the indexes, application team is creating the indexes in order to improve the query performance. Okay, that specific index related information will be storing in this index page. Okay, so that is the purpose we are using, like if any index is created on specific database, it is like that index related information is mapping with this IAM page. Okay, next, DCM, we call it as a differential change mapping. Okay, that means what is meant by differential backup, what is meant by differential backup, whatever the changes happen after full backup, after latest full backup, all these changes are, okay, logging into this differential backup, right? So whenever the differential backup, you insert any differential backup, that the differential backup related information is storing into the DCM page. Okay, so next, BCM, we call it as a bulk, okay, bulk change mapping. No, bulk copy, something. BCM means bulk change map. Okay, change map. Okay, like whenever you perform, like whenever user perform any bulk insert operations, okay, all this bulk insert are logging into this BCM page. Okay, and each and every page having separate page ID. Okay, I think the PFS, it is like PFS page free space, the page ID for this one is 0. Okay, and GAM and SGM, like GAM and SGAM, these are like 3 2. Okay, the ID for this GAM is 2, I think. Okay, this SGAM is like 3, and next we have 5 6 index, we have a 5, I think. So this is like 6. For each and every page we have a page ID. I will let you know exact IDs, but the boot page it is a 9. Okay, I will let you know that page IDs, exact page IDs later, but this is all about data pages. Coming to like extents, extend is a combination of pages. Okay, example, like we have uniform extend, we have no mixed extend, and uniform extend. Okay, these two are types of extends we have in SQL Server. What is mixed extend? Okay, mixed extend is nothing but a combination of, okay, mixed extend is storing combination of different pages. Okay, so that means it might be store database, it might be storing IAM page, it might be storing DCM, differential change mapping, it might be storing BCM page. Sorry. Okay, that means it is a combination of different pages. All these pages together is having only 8 pages. Okay, that means 8 into 8, 8 pages into 8 KB, 64 KB of size. Okay, uniform extent means it will store only same type of pages. It will maintain single page in this extent. Example, we have extent 1 2, like it will maintain all the same pages, same type of pages in this extent. Okay, so it will not like it will not allow to store any merge with any other pages. Okay, by default nature of the SQL server is mixed action. By default, whenever you insert or whenever you perform any data operations, it is considering the mixed extents. Okay, but by default nature is using the mixed extents, but here you have a problem. Every mixed extent is having one free space, one free space in the sense it is a problem. Why? Because if you take one extent, it is having only 64 KB. Example, you have database size is 1 TB. How many extents it is having? How many free spaces it is having? That means for each and every page, okay, it is storing, sorry, for each and every page it is storing one free space. That means, coming to in huge database point of view, huge size point of view, it is impacting a lot. So we have trace files, 1118 trace flag. Trace flag is one of the concept. I will explain it detailed view in later. Trace flags. Okay, see, we are enabling 1118 trace flag to avoid using mixed extent. Instead using mixed extent, it will automatically using the uniform. Okay, uniform extent is always best practices. Okay, but from 2019 onwards, SQL server 2019, the SQL server is by default using, by default it is enabled with 1118 trace flag. That means by default it is using the uniform extent. That means Microsoft is improved the enhancements of the database storage engine. You got it? So I will explain the trace flag later, but by default behavior is mixed extent. It is automatically allocating this mixed extent. Okay, so from the 2019 onwards, it is automatically allocating in this uniform extents. Okay, let me show you how it is displaying, what is mixed extent, how the data will be storing. Okay, so let me open pages extension SQL server. This is Microsoft official link. See, we have a separate architecture for the page, like page header, page free space. This is the page architecture, simple page architecture. These are the types of pages: data page, index page, global allocation mapping, shared global allocation mapping. Okay, page free space, index allocation mapping, bulk change mapping, differential change mapping. I will share this link with you, so you just go through it. See, this is the page architecture. Example, it is just like a normal page. Okay, so if you open this page, we have a page header, and inside the page we have a different rows. Okay, we have free space, we have a row offset, it is nothing but a address. Okay, and each and every like page header is 96 bytes. Okay, page header is 96 bytes, and actual page says how much KB it is. Like, what is the size of page? What is the size of page? 8 KB, right? example, this is the page, this is the page. Okay, so here we have like you can consider this is the header. Okay, this is like header. Okay, this page header is having 96 bytes. Okay, and remaining data page, actual page size is like 8196. How much it is? You can calculate. 8 into 1024, how much? 8126. 8 into, yeah, 8 into 1024. Total 8192. Sorry, it is
819.
8192, right? It is the actual total page size. Okay, if you want to calculate actual page size, 8192 minus yes, minus 96, how much? 80
106.
8096. 8192 minus 96, 8096. Okay, this is the actual page size. If someone asks, like, if you go in a Microsoft, if you attend Microsoft interview, they will just focus on only internals. What all are the types of pages, what is the purpose of each and every page, what is the page ID, what exactly it is storing, what is the logical unit. Okay, see inside the page what exactly you observed, how the data is segregated, you will get this kind of questions. Okay, so if someone asks like what is the exact page size, you can tell like 8096 bytes. Okay, by general you can tell like 8 KB, but out of 8 KB we have to like remove this 96 bytes because this is page header. Okay, so actual size is 8096 bytes. So let me open this diagram. This is the page architecture. Okay, so if you go down we can see extents. Extents are the basic unit in which space is managed. Okay, an extent is a 8 physically continuous pages or 64 KB. This means the SQL Server database having 16 extents per megabyte. Okay, per megabyte, that means 1 MB. For 1 MB 16 extents. Okay, so in SQL Server they have like divided into the two extents. One is uniform extent, one is mixed extent. Uniform extents are allowed only single object, that means single type of page. All 8 pages in this extents can only be used by the owning objects, that means same type of pages. It might be, if it is having index, it is having only index page, that's it. Okay, as per the performance best practices, uniform uniform extents are the best one. But mixed extent means it is shared by the up to 8 objects. Each of the 8 pages in the extent can be one by the different object, that means it might store different kinds of objects. See here, mixed extent is having like index pages, table 1, table 3. This table might be having like, or it might be having DCM, it might be having BCM, or the data or index or image, whatever it may be. Okay, but if you confirm this, if you take this uniform extent, it is storing same kind of pages, same kind of objects, single object. Okay, so this is all about SQL Server pages. If you want to check the SQL Server information, pages level information, this is a query, like this is a DME. We call it as a dynamic memory management view. DM underscore DB underscore database page allocations. How this page is allocating internally, you can check using this query. Okay, so let me copy and let's see the query here. You can directly open this. I will just show you how it is. select star from sys dot I think we have to supply some parameters. Internal allocation units, this is one of the query. We can modify, you can check the internal information. We have dbcc ind page also. I'm just checking for the query. Okay. What happened? We have one more command, dbcc page. We can also check the internal page level information using this command. It is to examine the table and index data. We have to dbcc page. Okay, this is the command. Basically I will explain this topic while explaining the page restore. We have page restore, one of the concept. They have a ind command. Yeah, I will explain this later. I don't think it is better time to explain. Okay, any doubts on this topic, let me know. Any queries on these pages or types of pages, types of backups?